Of all the planets NASA has explored, none have matched the dynamic complexity of our own. Deserts, tropical forests, icy poles, massive storms rage over land and oceans. A unique atmosphere protects and insulates us. Liquid water spans its vast surface, and a delicate balance of systems gives way to a kaleidoscope of life. Earth is a very special place. From the vantage point of space, the perspective of sky and sea, and all across the land, we study our planet not only to learn about it, but also to protect it.
Hello, everyone, and welcome to another episode of NASA Science Live. I'm your host, Dr. Kimberly Miner, and I'm so glad you could join us today for Earth Day. I'm a NASA climate scientist, and this year at NASA, Earth Day is all about connections. Our planet is home to over 7 billion people of diverse backgrounds and experiences, and we are all connected by Earth. NASA Earth Science shows us the ways that the natural systems like land, water, air, and ice connect to and affect each other and our climate. Earth's climate is changing, and since the mid-20th century, we know that human activity has been driving this change. Today, we're going to explore how NASA studies climate change and how that information is used worldwide. But first, let's start with the basics. What is climate change? I'm here today with Dr. Leslie Ott, a climate scientist at NASA Goddard, and Aquisha Glenn, research assistant and PhD candidate at NASA GISS, to break all of this down for us. Leslie, Aquisha, thank you so much for joining us today.
Thanks for having me.
Thank you for having me. So Leslie, we'll start with you. Tell us, what is climate?
So a lot of people get confused about the difference between weather and climate. You can kind of think of climate as the long-term average of weather. So say you have a friend who's thinking of moving to your city from out of state. They might ask you, what's the weather like? But what they really mean is, what is the climate like? What's the typical weather like? Things like, how many days in a month does it rain? When does the snow end in the winter? How hot are your summers in July and August? Those are the kind of basic pieces of information that affect our lives every day. And those are some of the reasons that scientists like us get so concerned when we see evidence that climate is changing.
Right. And now the reason why climate change is a cause for concern is because of the rate of change in these baseline average weather conditions that are being reported by cities all over the world.
Okay, interesting. So Aquisha, why is this happening? Tell us a little bit more.
Human activity. CO2 emissions from human-related activities are being released at an unprecedented rate. And this is considering a time span over 66 million years. So we have this large influx of carbon dioxide, which is a greenhouse gas, and this is accumulating in the atmosphere, is trapping and absorbing radiation, and this is driving temperature change at a rapid rate.
Okay. Thank you for the great explanations, you guys. I know I have more questions, and so do the people watching from home. So remember, you can join the conversation and ask your questions by writing in the comment box wherever you're watching this, or by using the hashtag AskNASA on social media. We're going to be answering all of your questions near the end of the show, so please do stay tuned. First, let's take a look at how NASA is studying carbon dioxide and its effect on our weather and climate here on Earth.
The Earth's atmosphere is a mixture of gases. Some are known as greenhouse gases. That's because they trap heat from the sun and warm the Earth. That's good, because without greenhouse gases, our planet would freeze, and life as most of us know it would be impossible. These greenhouse gases, mainly water vapor and carbon dioxide, naturally cycle between the land and atmosphere and ocean. And over the ages, these greenhouse gases have reached a delicate balance that results in temperatures that we like a lot. It's been that way for thousands of years, until the last 150 years. That's when people began burning fossil fuels. Those fossil fuels, coal, oil, natural gas, contain carbon that's been locked away from the natural cycle for eons. But when we burn them, that carbon joins with oxygen to make carbon dioxide that goes into the atmosphere. It throws the natural balance out of whack. The more carbon dioxide in the atmosphere, the more heat that is trapped, and the warmer it gets. And the warmer it gets, the more the climate changes, and the higher the ocean will rise. The more we learn about carbon dioxide and other greenhouse gases, the better we can deal with the changes caused by global warming. Because good planets are hard to find.
NASA studies Earth's climate so closely and with so many missions that we even have a climate advisor to the presidential administration. NASA provides real data for decision makers about our climate. Let's hear from NASA's climate advisor now.
My name is Dr. Gavin Schmidt, and I'm NASA's Senior Climate Advisor, which means I bring NASA's climate science to the public and help figure out how to apply it to saving the planet. I've been a climate scientist with NASA for more than 25 years, and I use Earth data and models to understand the past, present, and future of climate change. Climate change is one of the most complex issues facing us today. It is a global problem felt on local scales, and one that will be around for decades and centuries to come. Just as your doctor checks your health by monitoring your temperature and other vital signs, at NASA we keep an eye on the planet's vital signs. We keep track of the Earth's temperature, the patterns of rainfall, ice sheets, sea level rise, and the amount of carbon dioxide in our air. Thanks to NASA Earth Science, we know our planet and its climate are changing. And based on the evidence from the oceans to the upper atmosphere and from the tropics to the poles, we also know human activities are driving this change. As our planet's temperature rises, that will impact weather and extremes. This means more severe heat waves, more intense droughts, wildfires, and hurricane seasons. Many extreme events in recent years have been made worse by human-caused climate change. I look forward to helping decision makers at all levels find and use the information they need to move towards a more climate-secure future for us and our children.
And now we're back with Leslie and Aquicia. So tell us, Leslie, how is NASA data showing the connection between humans and climate change?
You know, before we had satellites, we had measurements of carbon dioxide from surface stations, but only a handful across the surface of the Earth. Those are really important in telling us how things are changing over a long time period, but they can't show us all the complexity of where emissions are coming from. In 2014, NASA launched its first dedicated carbon dioxide mission called the Orbiting Carbon Observatory. And since then, we've been getting these beautiful maps of carbon dioxide that fill in all of the holes that we had when we only had that handful of surface station many years ago. This is giving us so much more information about human emissions and where carbon dioxide comes from, but also where on the land and in the ocean carbon dioxide is naturally absorbed. And that's really important because the oceans and the land are playing this really important role in mitigating climate change by absorbing about half of human emissions. So we're learning so much more about how carbon dioxide is changing across the globe from this satellite view.
Amazing and wonderful satellite images. Aquicia, tell us a little bit about how climate change impacts our planet's weather, including things like fire seasons, hurricanes, and other natural phenomena.
Well, there are a wide range of impacts to the weather, and this is going to vary from place to place. So you have some places that may get drier, some places may be getting wetter. Seasons like these fire seasons and even blooming seasons can potentially shift. So they can maybe start earlier, they may be longer. You also have changes within the seasons themselves. So for example, you could probably get less snow during your winters. And with that, I'm thinking of New York City, right? I'm born and raised in New York City. And as a kid, I remember having to trek through snow. Like there was just always snow throughout the winter. It was just always there, just like a picture perfect snowy wonderland. But now as time has gone on and I've gotten older, I realized that we don't seem to have as much snow throughout the season. More so now we have these, especially in recent years, we have these severe events where we just get a heavy snowfall event and we just get dumped with all this snow within a few days or so within the season. So
Nice. Thanks, Aquisha. That was an awesome example. So it's Earth Day, and guess what? NASA will be launching astronauts to space tomorrow. These space explorers have a unique perspective of our home planet and that very few people get to experience. So let's hear a little bit more about it.
When you look out into the depths of space, you realize just the vast ocean of darkness. And we're on this little island.
Without a doubt, when you are climbing on your rocket, when you're launching into space, when the engine cuts out and you get to look back at Earth, absolutely every sacrifice is worth it. Every dream is worth it. The entire road there is worth it. Every bit of it is worth it.
It almost, I dare say, grieved me to think about how in the world am I going to describe this?
I will never forget that sight. The thin blue line of the atmosphere, the curve of the horizon. That's when it became real. Really, at a gut level, I'm actually in space.
All life is connected on this planet, and everything I do is in one way or another going to affect someone else that I share this planet with, or some other creature that I share this planet with.
The most significant realization to me was looking out and realizing not how far I was from Earth, but how close I was to Earth and how connected I was to Earth.
I'd give a lot to see that view again.
Incredible. Goodness. All right, well, we are now back with Leslie and Aquisha to answer some of your questions. I am really excited about this. So ask your questions by writing in the comment box wherever you're watching this, or by using the hashtag AskNASA on social media. All right, so let's start going through these questions. Our first question is from Bookworm on Twitter, who asks, how much time is left for humans to see drastic effects directly? Aquisha, will you start us off?
How much time before we see effects? I'm trying to see what context. Can you repeat the question? I'm trying to see, make sure I answer this.
So Bookworm was asking how much time for us to see drastic effects. So I'm thinking already of our fire seasons are getting longer and more extreme. We've got more hurricanes and they are also more extreme. So I'm wondering if we're already seeing some what we would consider drastic effects. Do you think so too, Aquisha?
Oh, yes. Yeah, we're already seeing them. As I mentioned earlier, cities across the world are reporting differences in extremes, especially in extremes, extreme temperatures, extreme precipitation events, a lot more flash flooding. So we're seeing a lot of those changes happening now, especially within cities and urban environments.
Yeah, absolutely. So we have two similar questions about the sun influence for you, Leslie. Mike Morales on YouTube and Jeremy on Facebook both would like to know if in climate science we account for sun cycles in geologic history. And further, how do we prove that global warming is not a result of the sun just burning hotter?
So this is a good question, and one of the climate scientists get asked a lot. And so we do have a lot of information to back this up. There's a couple different things I'd like to point to. First is some great work that's done by climate modelers, some of them in New York at Aquisha's lab at GISS. And what they will do is model simulations that look at every possible driver of climate change. Could it be natural variability from variations in the solar cycles, like you're mentioning? Could it be changes due to volcanic aerosols? Can we explain the changes that we're seeing through natural means? And when we do those detailed, realistic modeling studies, we realize that none of those changes can match up to the dramatic and abrupt climate change that we're seeing. When we add in greenhouse gas forcing, when we add in the heat that's being trapped by gases like carbon dioxide and methane, then we can explain very clearly what we're seeing. The second way that we know this isn't solar cycles or some natural explanation is that greenhouse gases leave a unique fingerprint in terms of the change that we're seeing. When we have greenhouse gases trapping heat close to the surface, that means the lower part of the atmosphere gets warmer. The heat's trapped close to us where we live, but the top part of the atmosphere actually gets a little bit cooler. So not only do we know from climate models and from ruling out that showing that natural explanations cannot explain climate change, we also have other types of observations that back up that this is in fact a signature that is consistent really with the greenhouse gases and not some of these alternative explanations that you might hear.
Great explanation. I think of a sleeping bag when I'm thinking about the way that it's insulating the inside and cooler on the outside. So we'll go to the next question. Maria on YouTube asks, or rather says, hello from Portugal. Hello, Maria. How does climate change affect the glaciers at the Earth's poles? And what influences do changes in the glaciers have in the lives of ordinary people? Well, I can answer this one, Maria. This is my area of specialty. So the poles are really, really important for a lot of different reasons. They reflect sunlight through something called albedo. They help us maintain circular currents in the ocean and in the atmosphere that we're used to, normal weather patterns. They also store a lot of water for us, which is really neat that we have almost like our own freezer and refrigerator available that we can store water in long term. So when glaciers or ice sheets start to melt, then we start to see fresh water moving into the ocean. We start to have less reflectivity on the surface of the planet and air currents change. And that's part of why we're seeing things like the polar vortex dipping into Texas. So a lot of the dynamics that are changing in the poles do affect the whole planet and really remind us, what is our theme today? That we're all connected by Earth. All right, great question. So next on Facebook, Ken asks, what happened to the glaciers in North America that formed the Great Lakes? Do either one of you want to address this?
It's a good question. I don't know, Kimberly, if you know this. This is a little outside my area, so you may be the expert on this one too.
So a lot of the ice sheets that used to be around in what we call paleoclimatology times, including the Laurentide ice sheet, receded with change in the climate over time. But remember, even though we know that the climate has changed in the past and things like the Great Lakes were formed, we also know that the rate of change is so much higher now, kind of like Aquiesha was saying earlier, whereas it may have taken thousands of years for these ice sheets to melt and recede, now it's taking 100, 150, and sometimes even less. Okay, Tio on YouTube asks, did the climate change before, or how did the climate change before humans? We've touched on this a little bit, but let's talk a little bit more about it. Leslie, did you want to start us off?
Sure. You know, and Aquiesha mentioned this. There has always been natural changes in climate, and some of those are related to the natural drivers that we had a question about a minute or two ago. We have natural variations in things like solar energy, volcanic aerosols. There are certain things that are changing naturally that force the climate system. So we do see more subtle and longer term shifts in temperature and things like ice. And so those are some of the kinds of changes that we've seen in the past. Of course, we have limited information about changes that happened thousands of years ago, because we didn't have satellites, certainly we didn't have surface instruments, but we do find evidence of those in ice cores or sometimes in sediments on the ocean floor. So we have some knowledge of what the climate was like a long time ago. We know ecosystems were different. We know different species existed in different places because of that. And so, we have some pieces of information, but again, the point that's been brought up several times that I think is important is we know there's this natural variability, but on top of that, this very massive signal that's caused this very rapid rise in temperatures and the rate of change that we're seeing.
Thanks, Leslie. Amazing answer. I want to skip to the next one because I think, Aquisha, this is perfect for you, I hope. Zay on Twitter asks, can you see climate change from space? And maybe I could even add, what data and tools do we have to see climate change from space, Aquisha?
Yes, we can see climate change from space, as Leslie had touched on earlier. NASA does have a lot of missions where there's monitoring the CO2, ocean temperatures, land surface temperatures. So with satellite, which the great thing about satellite data is that it measures information about the surface of the Earth, but in the electromagnetic spectrum. So because of that, it's not simply just taking a photograph, but there's information within these pixels. They're assigned these things called digital numbers, and we're able to transform those into other variables that we're interested in. So we can take these numbers and we can calculate land surface temperature and observe temperature changes, not just on a global scale, but on local scales within cities. We can also look at things like precipitation as well. So there's a lot of ways that we can monitor climate change, but also derive different variables to help us understand more things about the climate factors.
Nice, that's awesome. Thank you for that explanation. So Christian on Facebook now asks, are there runaway effects of climate change that we should be wary of? He says, for instance, we hear a lot of mixed news on snow cover melting and reducing the amount of heat being reflected back into space. So I touched on that a little bit. Leslie, do you want to pick it up and talk more about runaway effects of climate change?
Yeah, it's a good question. And it's something I will say, I think there's debate about this, and I don't think that we totally know the answer. This is something we're still working hard to address. And this is something we studied with satellites. We actually have field campaigns that go out and measure in great detail to make sure we can understand the processes. This is one of the ways that we create climate models is we take all the information we have. We try to write equations about how some of these processes interact with each other, and then we run very long simulations to look at how things are changing. And sometimes there's uncertainty in the long-term projections, which leads to uncertainty about how much of these feedbacks effects we're seeing now versus how much we expect to see in 20, 50 years, right? But this is certainly a cause for concern. So Kimberly mentioned surface albedo. There are feedbacks often of opposing signs. So let's take water vapor, for example. Water vapor is a powerful greenhouse gas, but it's not direct. It's not just controlled by people, right? There's natural processes like evaporation and rain. So a positive feedback process would be something that magnifies the warming. So for example, when we warm the planet, we have more capacity to hold water vapor. We evaporate more water vapor. That can be a positive feedback, adding to global warming. At the same time, if we put more clouds in the atmosphere, they can also reflect sunlight. They can actually keep some of the sunlight from reaching the Earth. That's a negative feedback. And so the response is the adding up all of these complicated positive and negative feedbacks and to really understand the trajectory of the planet. And so that's really where I think we are right now, is really trying to understand those processes, make sure that we have a good handle on them, and then monitor for signs of abrupt change, because this is of course a concern. But that's a very good and insightful question that hits on what underpins a whole lot of our work.
Yeah, that's a good point. There's a lot of very complicated things that already happen on Earth. So building a model that captures all of them is such a challenge. So Diana on Facebook asks, do volcanoes have something to do with climate change? Do one of you guys want to take this one?
I can take it unless Aquisha wants to.
You can take this one too.
So it's a great question. So obviously volcanoes erupt naturally, and they have for a really long time. That's some of the reasons we have islands and vacation spots where they are, right? Because a volcano erupted thousands of years ago, and now there's an island there. So there's volcanoes erupting is not related to, a result of climate change. But what volcanoes do is emit large quantities of aerosols, especially powerful eruptions. They can spew masses and masses of aerosols, these tiny little particles that get suspended in the atmosphere. And in the case of really, really big volcanic eruptions, they can emit such powerful ejections of aerosols that they can actually make it into the upper part of the atmosphere that we call the stratosphere. That's important because that means they can stay in the atmosphere for a very long time. They can kind of hang around, and you get this sort of aerosol haze. And that aerosol haze from volcanoes can actually reflect sunlight. So it can actually have a cooling effect. And we've seen this in recent years, in that in the most recent big example that people studied a lot is Mount Pinatubo. So there's been a lot of research on some of the effects of Mount Pinatubo. So there is this sort of important temporary effect of cooling that can come from really only the largest volcanic eruptions. But again, what we talk about there in terms of scale of how long the cooling would last, typically a couple of years, maybe, on the order of a few years. When we talk about human-driven climate change, we're talking about things that are going to last for centuries or much longer time scales. So volcanoes are part of the sort of natural variability in the climate system. And one of the things that, is very interesting to study, makes our jobs quite fun to watch all of these different changes and try to figure them out.
Okay, so we only have 1 minute left, and I want to see if we can just do very quick summaries, because I think this is an important question. Atlantean on YouTube asks, what makes you think that it is not too late to stop the worst outcomes of climate change? We are talking a lot today on Earth Day across all different spheres, all different parts of the government, about how important it is for us to do rapid, urgent changes in order to halt some of the progression of climate change. What is your guys' thought? Why is it not too late?
I can go. It's not too late because I just think about the strides we made just in technology, and just the fact that we're even here on this video call. We couldn't do this how many decades ago, right? So I definitely have faith and hope in the 7 billion superpowered brains that we have if we collectively work together. I'm very hopeful that we can come up with solutions. We've done so many things so far. Sending people, we're sending people to Mars. I mean, we have the ability to make changes. So that's my take.
Well, those were amazing questions. Thank you all so much. And if we didn't answer your questions here, Aquish will be answering more questions tomorrow from 12 to 2 p.m. Eastern Time on the NASA Goddard Twitter account. So please visit her there. And if any of the questions we didn't get to, she can answer them. Thank you so much, Leslie and Aquish, for joining us today.
Thanks again for having us.
Thank you.
Well, that was really fun. Thank you so much for joining us at home. If you want to learn more about NASA's efforts to study global climate change, you can visit climate.nasa.gov. Throughout today's episode, you've seen how connected our planet and systems are. Each of us is part of the gorgeous mosaic of Earth, and on this Earth Day, NASA is asking people around the world to share how we are all connected by Earth. Join us by posting an image on social media of the bit of Earth that connects you to our planet. Feel free to include yourself and tag it with #ConnectedByEarth. Here are a few of the awesome images that have already been submitted. To stay updated on the research of our home planet, follow NASA Earth on Facebook, Twitter, and Instagram. And thank you so much for joining us today. We'll see you soon, and happy Earth Day.